We're going to take one last look at graphs. So we had a question very similar to this and gotten rid of all of the start of it. So basically, suppose we're told that we have two functions, f and g, and that f dash x is equal to this, and g dash x is actually equal to the same thing. And we're asked which one of these could be the graph of f and g. So the first thing I suppose is that because the derivatives are the same, that means that the slopes of the tangents are the same everywhere. And that means that the curves are parallel. So it can't be B. In A, the curves are, when this is going up like that, this is going up like that, this is going down, this is going down. B is not parallel, therefore it's not B. So the question then really is it A or is it C? Now, because there's no ticks on the axis with labels on them, I have no idea where, for instance, the point 1 is. The point 1 might be in there. The point 1 might be out here. The point 1 on this graph might be all the way over here. Okay, that might be a half, that might be a quarter, that might be an eighth, that might be a 16th, that might be a 32nd on this particular scale. I don't know. So the only point that I know for sure is when they're on the axis, and that's when x is 0. So what I need to do is I need to look and I need to see what's f dash x when x is 0. So at x equals 0, f dash of 0, if I fill in 0, is 0 plus 1 over 0 minus 1, which is 1 over minus 1, which is minus 1. So that means at x equals 0, they should both be sloping down with a slope of minus 1. Now if you go back to the pictures, it's definitely not B. At 0, these are sloping like that, and these ones are sloping like that. So it cannot be A, because at 0, A is sloping upwards, so it must be C. Therefore not A. At 0, A is sloping up. Therefore, it must be C. Okay, it's important that you see that there is only one point that I can identify on the x-axis. I can't identify 1 or 2 or 3. The only point I can identify is when x is 0. So I'll test it when x is 0. I'll see what it is, and that'll tell me what the slope of the derivative should be as I leave the y-axis. So at the point where x is 0. And at the point where x is 0, these slopes are going up, these slopes are going down. It cannot be these ones. No matter how that axis there is squashed in or stretched out, this cannot be correct, because these are going up and these here are going down. So this is the only one that it can be.